Welcome to 10.2, friends. Let us have at it. Okay, number one, this is a throwback to your previous years of math. Proportions, really what you need to know about proportions, that's just when I have a fraction equals a fraction. Another way we could also think about it is, see on the left side for part A, 8 divided by 3 equals x divided by 8. Well, I don't know if you guys remember, we're going to do what's called cross multiply. And so help me, some of you are going to say, oh, it's the fish. This is not a freaking fish, people. This is math, okay? Cross multiply, meaning you are multiplying what's on the diagonals from each other because that's what's canceling out the division from both sides. So 8 times 8 gets me 64, which equals 3 times x. And now I can divide both sides by 3. Lo and behold, I get x equals, oh my gosh, my brain lost it. Stall while I get a calculator. Here, this could be our Dora the Explorer moment for the day. What is 64 divided by 3? Oh, it's not an even number. Fun fact. $21.3 is what we get. Now I don't feel as bad for not knowing that. Okay, I can do the same thing with any of these. So let's just jump to part C just because. Cross multiply 6x equals 35. Wow. Get used to decimals, I guess. Okay, let's do something like part E. Ah, snap. You see how now I have a binomial on the top left? So that's going to be like 12 times all of x plus 1 equals 4 times 1, which I know is 4. So I'm going to distribute that. 12x plus 12 equals 4. And now we're just going to get x by itself. So I can say x equals negative 2/3, which is negative 0.67. What are we learning? Get comfortable with decimals, apparently. Okay, part F, this is the big one. 2 times 2x equals x minus 4 times x minus 6. Man, so much distribution is about to happen before our eyes. X squared minus 6x minus 4x plus 24. I'm going to combine like terms, and I'm going to minus this 4x while I'm over here. So we get 0 equals x squared. Negative 6 minus 4 is negative 10 minus 14x plus 24. Ooh, quadratics. You guys remember what we do with quadratics? Factoring. Okay, what multiplies to 24 but adds to negative 14? Dora Explorer, go. Very good. Negative 12 and negative 2. And because my a value equals 1, meaning I don't have a coefficient in front of x squared, we can use the shortcut, so I get x minus 2 and x minus 12. Well, that equals 0, which means my solutions are 2 and 12. Well, that was a fun time. And you might be freaked out by part F. I promise you part F is the most complicated thing that I'm giving you on this notes. The homework is not even that bad, so don't even stress. Okay, let's talk about something called similarity. Okay, examine the two triangles below. What are their similarities? So what's the same? Let's see. They all have the same angles. What about the side lengths? Take a minute and just look at those side lengths. What do you notice between the two? I hope you noticed that. I could take 10, and if I times it by 2, I get 20. I could take 6, times it by 2, to get 12, 7, times it by 2, to get 14. So what we're looking at here is we're actually looking at what we call two similar triangles. So if shapes are similar, this means that all the angles are congruent. And all side lengths are proportional. Okay, here's what I mean by proportional. Basically, if side lengths are proportional, it means that every side has been multiplied by the same number, which is what we call the scale factor. Proportion, like we talked about up here, see how it's a fraction equals a fraction. So what I could look at down at this example is looking at the corresponding side length. So I see 10 to 20. I can say that 10 over 20 is the same as 6 over 12, which is the same as 7 over 14. See how all of those come out to be 1/2? So this is what it means when it says all side lengths are proportional, meaning if I set them up as fraction over fraction with those corresponding sides, then it's going to equal that same value. Like I said, that's proportionality. Another way to think about it, oh, I see they're all multiplied by 2. That 2 is what we call the scale factor. And so as long as all sides are multiplied by the same scale factor, then we have what we call similar figures. So for this part, we're just going to identify corresponding sides and corresponding angles. So up here is what we call a similarity statement. This guy right there. This tells us which sides are similar to which and which angles go to which. So corresponding sides and corresponding angles. Well, I'm just going based off this. I know that K, we go from left to right. Angle K corresponds, or I'm going to say is congruent to angle K, because guess what? All angles have to be congruent. That's what we learned in this statement up here. So then I know what comes next. Angle L is congruent to angle Q. And coming next in that statement, angle M is congruent to angle R. Those are my corresponding angles. Well, if I'm looking at side lengths, all I'm going to do is look at the order of this. So I see it starts with KL to KQ. So I know that KL is similar to KQ. There's a new symbol for you. That little squiggle in between, that means is similar. Well, I could also, in that same vein, well, up next is LM to QR. So we know LM is similar to QR. And my last pair is KM to KR. So it's all this, the focus of this part is just using your similarity statement to decide which sides go with which. So let's do just one. Actually, I think that's okay enough to move on. If you have other questions about please feel free to send me an email, or you can request sign up for a conference call with either myself or Mrs. Whitehead if you're in B5 or B6. Okay, so what we have to do is, knowing that these figures are similar, well, we're going to take that knowledge and try and find a missing length. So here's what this looks like. Part A, I see some side lengths. I've been told they're similar. Here's what we know. I know that JK is the 90, and that corresponds to TU, which is my question mark. Let's call that x. I also know that KL corresponds to UV. And so I have a few different options of how I can find this. Either we can set up a proportion or we can find the scale factor. I typically usually like to set up proportions. I'm going to show you both ways because math space more focuses on determining the scale factor. So let's say scale factor method. Well, to get from 54 to 12, what did we do? Here's what we like to do. Scale factor is usually represented by the letter K, and the scale factor, let's come down here. This is the value. Multiply each side by. And this is represented by the letter K. So I know that 54 times K is going to give me 12. So if I want to find out what the scale factor is, we're going to divide that by 54. I'm going to pull out my calculator. Nope, it's 12 divided by 54. I get like 0.22 repeating. So that means if I want to get from 54 to 12, we multiplied by that 0.22. Because it's an ongoing decimal, and so I can't type that correctly in my calculator, I'm just going to reduce that fraction to get something a little bit more precise. So 12 divided by 54, math frac that thing, I get 2/9. So I just knew that I had to multiply this by 2/9. So that means to find x, well, I'm just going to do the same thing. I'm going to take 90 and multiply it by 2/9. So 90 times 2/9. And you get 20. So that's the scale factor method of just, finding, okay, what did I multiply this side to get to the next one? Let's do part C with the scale factor method as well. Here's what I know. LM corresponds with LU. And I know, oh dear, sorry. Let's come back. Okay, we're back. All right, I have C side LV that goes with LN. I think a lot of you can look at this and decide, hey, what is the value of x? I'm hoping you can see that x is going to be 22. Well, how did we know that? Well, to get from 11 to 22, we can multiply by 2. So I'm going to do the same thing with this one. Times it by 2. And that's where we get that 22. So that's our method with scale factor. We also have the option of setting up proportions. And I'm showing you both methods because quiz asks for one, math space asks for another. And so I just want you to know how to do both. Okay, here's our proportion method. Let's pick a fun color. I think this bright purple is going to make me happy today. All right, let's see. UV corresponds with UK. And I know, let's see, UW corresponds with UL. Okay, so in the method of setting up proportions, basically I'm just setting up a fraction between the two corresponding sides. So it doesn't matter which way your proportion is set up as long as you're consistent in your directions between triangles. I'm going to go left to right just because I read from left to right. If I want to go to the other direction, I could. So here's what I'm going to do. I know that 18 over 84 equals x over 98. Well, hey, now I have a proportion, which means we can just cross multiply that to get 84x, 18 times 98, which equals 1764. And now I'm going to get x by itself by dividing both sides by 84. We get 21. Okay, D and E, these look a little bit different, but I want you to look. How many triangles do we have? See how I have a small triangle, but I also have a big triangle. So in these cases, I think it's easiest to just draw it out again and label everything. So it looks like this is X for my question mark. That 30 is referring to that side. We got 15, 55, 77, 110. Okay, so our corresponding sides here are the ones that came from the same side over here, if that makes sense. So like for example, the 77 goes with the X. So I can just write 77 over X. And then this is a choose your own adventure moment. Which side do you want? Maybe I want to use the 110 and the 30. 110 over 30. Notice I was consistent from going big triangle to small triangle, big triangle to small triangle. And I can cross multiply 77 times 30. Oh, this is a calculator heavy day. 2,310. Now we're going to divide both sides by 110. Hey, look, x is 21 again. Okay, so moral of the story, we had our scale factor method, we had our proportion method. It doesn't really matter to me which one you use as long as you're understanding how it works. Like both of these methods work, and so I'm okay with either one. Something that I want you to know more specifically with scale factor though, if I'm multiplying both sides by a number that is bigger than 1, that means the shape is going to get bigger. If I'm multiplying by a number that is less than 1, here I'm just going to write greater than, then I'm going to write less than. If it's less than 1, then it's going to be a reduction. So for this one, find the scale factor of the polygon on the right to the polygon on the left, then state if it's an enlargement or a reduction. So that means it wants to know, oh, this brings up a really good question. Wow, I'm so glad I put this in your notes. Notice there's no similarity statement. Darkness. Well, here's something important to know. I'm writing this in red so you know it's going to be important. Biggest to biggest, smallest to smallest. Here's what I mean by that. If I have the largest side of the triangle and I multiply every side by the same scale factor, that largest side is still going to remain the largest side. And that cannot change. So when I'm looking to see if it's an enlargement or a reduction, I think we can see that this is the hypotenuse of the triangle. So no, those are going to stay the same. Well, between 21 and 18, 18 is smaller. Between 12 and 14, 12 is smaller. So those are one set of corresponding sides. To find scale factor, you only need one because they'll be the same. I'm trying to find what do I multiply 12 by to get 18. So once again, that's 12 times the scale factor gets me 18. divide both sides by 12. If I'm going to reduce that as a fraction, I get 3/2, or it's 1.5, doesn't matter which one, right to me. Well, hey, I see that's bigger than 1, and I see that the triangle got bigger, so I know that's an enlargement. Let's come over to part C. Here is my bigger piece. Here is my bigger piece. Here from 28 to 7. Some of you might be able to see that we divide that by 4. Well, dividing by 4 is the same as multiplying by 1/4. If you weren't sure about that, you can just do 28 times the scale factor gets me 7, and then we can divide, and we get the 1/4. If I wanted to put that as a decimal, I could. See how this number is less than 1? Also, the shape got smaller, so I know that this is going to be a reduction.